Okay, so welcome to this week's sheet. We're looking at the factor theorem here and a couple of applications. So just to recap, the factors theorem states that for some polynomial p of x, if p of b over a equals 0, then ax minus b must be a factor of x. That is all it states. It doesn't go the other way. Always remember that it goes p of something equaling 0, implying that there is a factor of p of x. Okay, so we're going to look at two examples. These are the ones at the top of the sheet, and then there are some questions to do as well, and the solutions will be available later on. Okay, so here we're given that x minus 2 and x plus 1 are both factors of f of x. So, using the factor theorem, f of 2 equaling 0 implies that x minus 2 is a factor. So substituting that in, we end up with 2 cubed plus p times 2 squared plus q times 2 plus 6 equaling 0. So 8 plus 4p plus 2q plus 6 equals 0. And I can rearrange that then to say that 4p plus 2q is equal to negative 14. And that's going to be my first equation. Also, f of negative 1 equaling 0 implies that x plus 1 is a factor. And so I can substitute in negative 1 and set that equal to 0, and I get another equation. So minus 1 cubed plus p times negative 1 squared plus negative 1 times q plus 6 equaling 0. So we've got minus 1 plus p minus q plus 6 equaling 0. So therefore p minus q is equal to negative 5, and that's my second equation. So solving 1 and 2 simultaneously, and I would use your calculator for this. There is no need to do it another way. So let's substitute these two equations in. We've got two unknowns. And we end up with p is equal to negative 4, and q is equal to 1. So I'm going to use that to factorise fully in part B. So from part A, p of x was x cubed minus 4x squared plus x plus 6. And we know that x minus 2 times x plus 1 is a factor. i.e., if I just expand that, x cubed minus 4x squared plus x plus 6 is going to be x squared minus x minus 2 times by some number of x and then a number. Well, to get the x cubed, I must just have x. So I'm going to have 1x there. And then to get a plus 6, I must have a minus 3, negative 3. Let's just check that that works. So if I look at my x squared terms, we've got a minus 3x squared and a minus x times x, so minus 4x squared, so it does work. So hence, x cubed minus 4x squared plus x plus 6 is equal to x squared minus x minus 2 times x minus 3, but leaving that in fully factorised form, i.e. the three possible linear factors, x minus 2, x plus 1, and x minus 3. So for this one, I'm able to leave it as three linear brackets. Sometimes we'll have a quadratic that isn't reducible into two linear brackets, as you'll see in the next example. So moving on to example 2, it's a bit more involved. I want to show that 2x minus 3 is a factor. Well, to do that, we're going to evaluate p at x equals 3 over 2. So if I do that, and I want to show that I'm substituting in the value here. So 2 times 3 over 2 cubed minus 3 over 2 squared plus 13 times 3 over 2 minus 24. And let's just double check that that does work. We know it should equal 0. So we do get 24 from those first three terms, minus 24 equals 0. So since p of 3 over 2 equals 0, by the factor theorem, and make sure that we state this. So by the factor theorem, 2x minus 3 is a factor of p of x. Now part B, I'm going to do by inspection. You may like to do this by reverse grid, polynomial division. All of those methods are valid, and if you would like, I will show you both other methods as well as a supplementary video. Just let me know. So for B, I'm going to find the quadratic factor. So I'm going to say that 2x cubed minus x squared plus 13x minus 24 is equal to 2x minus 3. And I've now got a quadratic here. And I know that what I'm looking for is some quadratic ax squared plus bx plus c, and I just need to find what that quadratic is. Well, I'd work inwards, so I'll do the a and the c first, because for the a, to get the 2x cubed, I've got a 2x in my first bracket, so I must have just x cubed here. And then to get the minus 24, I must have a plus 8, because this negative 3 will be multiplied by plus 8 to give the negative 28. So that's going to be a plus 8 at the end of my quadratic bracket. And I can start looking now at the x squared terms. Well, to get an x squared term, I want to have a total of negative 1 x squared terms. At the moment, I can get an x, sorry, just a little mistake there. just to check, I said it, but the 2x, there must be an x squared, not an x cubed. So to get the negative 1x squared term, at the moment I've got minus 3 times 1, which is minus 3x squared. I want to add another 2x squared to get the end up with minus 1. There must be a plus x here. Hence, that is my quadratic factor. Okay, for part C, if there's only one real solution, then that quadratic x squared plus x plus 8 must have no real roots. So we're going to consider the quadratic x squared, so let's call that q of x squared plus x plus 8. So I can now work out the discriminant, because remember the discriminant is what we can use to categorise the type of roots of a quadratic. The discriminant q of x is, and sometimes it's often helpful to write out the values of a, b and c. So a equals 1, b equals 1, c equals 8. So I can now calculate the discriminant. So the discriminant is 1 squared minus 4 times 1 times 8, which is 1 minus 4 lots of 8 are 32, so minus 31. So since the discriminant q of x is negative, the equation x squared plus x plus 8 equals 0 has no real solutions. And so 2x cubed minus x squared plus 13x minus 24 has only one real solution, which we know is x equals 3 over 2. Part D then, it's a disguised quadratic. So if I let y equal e to the x, then the equation 2e to the 3x minus e to the 2x plus 13e to the x minus 24 equals 0 just becomes 2y cubed minus y squared plus 13y minus 24, which from part C has y equals 3 over 2 as a solution. But y equals e to the x, so hence e to the x equals 3 over 2, and taking logarithms of both sides, x is equal to ln, natural log of 3 over 2. Okay, so thank you very much. If there's any questions, please let me know. Drop me an email or come and find me. Good luck with the other questions on the sheet.